Good morning, everyone. Today we're going to start our discussion of panel data regression. So far we have discussed multiple linear regression, and we said that in multiple linear regression, what we analyze is okay. So let's have a quick review, class: cross-sectional data, time series data, and panel data. Okay. So for we take a look at it in terms of the number of units and the number of periods. And we said that for a cross-sectional data, you usually have many units, okay, many, and then one time period. So as an example, you're taking a look at the a cross-section of of the hourly wage of individuals. Okay, so you have let's say 5,000 different individuals coming from different companies, different locations, and then you measure their hourly wage. Okay, you look at their profession, their educational attainment, etc. And these are taken at a specific point in time. Let's say in the month of November 2025, you gather that information. So that type of data is called a cross-sectional data. Okay. On the other hand, if you were only taking a look at one individual, let's say one individual, okay? Sorry. So just one individual. So we have just one individual. Okay, for example, Mr. De La Cruz. However, for the period of time you were tracking his hourly wage since let's say 1990 until 2024. You were tracking his hourly wage, okay, across for several periods of time. So this is 34 years. Okay, and you were tracking just one individual. You were tracking the hourly wage of this person, average hourly wage, let's say per year or per month even. So that type of data is what we call a time series data. The focus is only on one individual or one unit, as compared to a cross-sectional data where the focus is on many units. Okay, but the period is one period of time. Okay. On the other hand, panel data is a combination of cross-sectional and time series. So you're taking a look at many units, many individuals, and then many periods of time. So to illustrate, for example, you're taking a look at let's say ASEAN countries. ASEAN, let's say ASEAN 6, Philippines, Malaysia, Thailand, Indonesia, Vietnam, and Singapore. Okay, and we're tracking the, let's say, the employment rate of these countries. Okay, we were tracking it from 1970, or let's say year 2000 until year to 2024. Okay, so the question is, how many units are we looking at? We're looking at the ASEAN 6. So many units. Okay, and then what periods of time from year 2000 up to 2024. So that's many periods of time. So that type of data is what we call a panel data. Okay, so it's important to recognize the difference between a cross-sectional data, a time series data, and a panel data. Okay, so class, when you choose your data for your case, make sure it's a cross-sectional data. I've seen some students choose data that contains the time element. So merong 2010, 2011, 2012. That that ceases to be a cross-sectional data. Okay. Now, why am I saying that you should not use a time series data class for your case in multiple linear regression? It's because there is a specified way to analyze time series data as compared to cross-sectional data. Okay, for cross-sectional data, you're not concerned about the order. So you have, for example, several countries. Okay, you're taking a look at the let's say the GDP of all the countries. Okay, in 2024. So you have a list there, how many countries? Let's say 200 countries, 2024 GDP. Okay. If it's a cross-sectional data class, it doesn't matter well, how you order your data. It can be alphabetical. It can be sorted by the highest GDP, or it can be sorted by the lowest GDP. So the order does not matter, class, because there's no logical order. Okay, unlike a time series data class where you have a logical order. So you cannot just simply arrange it by alphabetically. You cannot arrange it by uh, sorted by from A to letter Z. Eh, hindi siya pa pwedeng ganun kasi class, the order of a time series class has a logical order. So what will appear first should be the earliest, no? 1990 to 2024. Okay? So I hope that's clear, class. May I have a feedback from you, class, kung clear yung distinction ng cross-sectional, time series, and panel data. For your case, it should be cross-sectional data. Kindly please, class, if the explanation is clear, yes lang, or kindly confirm. Okay, good. Medyo may, okay, mabagal yung response time, class. So medyo may hangover pa yata kayo. Okay, waiting for your response, class. Let's go. Let's have more responses, class, please. Okay, good. All right. So for today, class, we're going to start our discussion of panel data. And then next week, we're going to time series data. Okay. As I said, please open a new RMD file, project class. You may name it panel data. Okay. So we're going to load some packages class here. So kindly use Pacman. Make sure your Pacman package is loaded. Pacman, your Pacman. Okay, make sure it's checked class. And then let's load these packages. LM test, sandwich, and stargazer. Although I think before we already loaded this, but it's okay. So let's load that class. I'll give you a few seconds. PLM, LM test, sandwich, and stargazer. Once you're done, class, kindly please chat. Let's wait for your classmates. Request again, class, when you respond, please uh, respond to everyone. Okay. 4 responses out of 26. So it's quite a low response rate. Yung iba class, I never see you respond. No? I know, no? Yung mga ibang halos, never once ko nakitang mag-respond. Of course, you know who you are. Okay. So we're going to use data coming from the PLM package. So let's first look for the PLM package and see what what this is class PLM. Let's click this. This is for panel data class, linear models for panel data. Okay, if you check what this is about, description. So this is a set of estimators for models and robust tests for panel data econometrics. So okay, there is a special package that deals with panel data, and that's PLM. Okay, so what's inside this PLM? Let me go back, and you can see here that in the PLM package, it has some data in it. Okay, like gasoline, Grunfeld's investment data. Okay, so we'll start with looking at Grunfeld here. Okay, so we're going to load this data, and here, let's load the Grunfeld data from PLM. We can write data Grunfeld, or you can identify the package. Grunfeld package is equal to PLM. It will both run class because there's Grunfeld. Uh, I'm if I'm not mistaken, it's not found in other packages. But let's use the Grunfeld data coming from the PLM package. Okay, let's run this, and then let's view. Let's see what Grunfeld data contains. Okay, so firm, year, investment, value, and capital. And there are 200 observations. Okay, once you have the data class, kindly chat. Kindly chat, please. Kindly confirm if you have the data. Okay, good. So waiting for the others. Okay, okay, good. Okay, again, request to please chat to everyone, not to DM me. Okay, so if you take a look at the data class, you have the first observation here is firm. Okay, why don't we also open this class, Grunfeld? And this is a balance panel class. Take a look. Balance panel. Okay, so what does balance panel mean, class? From 1935 to 1954. Okay, so if you take a look at the year here, class, 1935 up to 1954. This is actual data. So that's a firm one. When you say balance panel class, it means that the units, okay, all the units are present across all the periods. Okay, so that means that firm 1, 1935, okay, 1935 up to 1954, it's present. Firm 2, 1935 up to 1954, it also has data. Up to firm number 10, 1935 up to 1954. That's a balance panel class. 10 units from 1935 to 1954. That's 20 years, no? 20 years, 10 units class. And since it's a balanced panel data, you have 200 observations, 10 times 20. Now, an unbalanced panel data is one where a particular unit might appear in in some periods, but does not appear in other periods. So if you have a data, for example, from let's say 1970, you have let's say 10 countries first, and then across the future periods, let's say 1990 na, no? And then there are now more than 10 countries. So let's say there are now 15 countries. Maybe some were added along the way. And those original countries in 1970, some of them are no longer present in 1990. So when you have an instance like that, you have what we call an unbalanced panel data. Okay. Can we still do perform regression on that? Yes, we can still do that. But it's best class to have a balanced panel data for comparison so that you can compare the whatever you're analyzing across the years. Okay. So good thing we have a panel data coming from the PLM package, Grunfeld. So okay, let's now get the structure of this STR. And you can see that it's a data frame, 200 observations, 5 variables. What are the 5 variables? Firm, year, investment, value, and capital. So this is what makes a panel data different from a cross-sectional data. Okay. And this is also what makes a panel data different from a time series data. For a time series data class, you only have one unit. In this case, there are 10 units and then across many periods of time. So this makes it a panel data. Okay, so let me pause for a while and ask you class if the concept or idea behind a panel data is clear, class. Okay, good. Thank you. Aika, kindly reply to everyone na lang ha, please. Okay, good. Okay. All right. So, okay, take a look now at what we're doing. So the first step, class, in dealing with panel data is to make sure that the panel data is treated as such. For now, it's a data frame. Okay. Our data, Grunfeld data, is a data frame. So what we're going to do now is we're going to create we're going to create an object called p data. Okay. And then we're going to convert our our data frame into a panel data. So using the PLM package, we use this function pdata.frame. So this is panel data.frame, okay? And then the object is Grunfeld, comma, and then we identify the index, okay? So what's the index? The first one should be what's the unit? Okay, the second one should be what's the time period? Okay, this is very important, class. In case your data, class, some data may have the year first, no? Year and then firm. But in the P data frame class, you have to start first with the firm or the unit and then the year. Okay, so I'll give you a few seconds, class, to check this out. And then we'll go back here to this P data frame just to make sure that you uh, write the index properly. Okay, so once you have written this class and then get the view and the structure, tell me, class, what's the structure of this data now? The P data, where we are preserving the Grunfeld data set, class. So let's just create another data set called P data. Okay, so could you kindly please run that, and then tell me what type of data is P data? Is it still a data frame? I'm not giving you the code, class, kasi simple lang naman siya. I want you to write it yourselves. Hmm. Okay, thank you, Chard. Okay, how about the others? Waiting for the others, class. Okay. Okay, thank you, Jerry Lane. Adrian, thank you. Let's wait for your classmates. I want everybody to be on the same page. Let's just make sure that they also have the P data object. Okay, good. All right. Okay, thank you. So a few more seconds. Less than 10 lang talaga nagre-respond. Okay. Okay. All right. Let's go back here, class, to our to the PLM package. Let's check here. Here, class. pdata.frame. Okay. Click natin to, class. Let's click this. And what does it tell us? Object of class pdata.frame is a data frame with an index attribute that describes its individual and time dimensions. Okay. So here, index. See details. Kasi index niya. Okay. So just make sure, class, that when you write the index, okay, make sure that the one that you list first is the unit and then the year. Okay. It doesn't matter if they're separated. See, sometimes the year might be the first column, and then you might commit the mistake of putting the year first in your index. Okay, so just make sure that it should be the the unit first, and then the and then the period of time. Okay, so let me run this. So just like in your case, class, I now have, okay, class p data that frame. So it's actually a combination class, no? Panel data and then a data frame. Okay. All right. So that's our object there, p data, that frame. Okay. So let's move on, class. And okay, let's now do a regression model, class. What we're doing here is we'd like to create a model, class, for investment. So we'd like to predict investment. We'd like to create a model for investment using value and capital. So for panel data, class, there are three methods that can be used. So we have first is the pooled OLS. Pooled. Pooled ordinary least squares. Then you have your fixed effects. Fixed effects. And then your random effects. Random effects class. Okay. So three methods: pooled OLS, fixed effects, and then random effects. Okay, we're going to study them one by one and see which which of the three best fits our data. So in a panel data regression class, you have to check the three methods. And then there are statistical tests to determine whether it's the pooled OLS or the fixed effect model or the random effects model that best is best used in our data for our data. So let's first create this. Okay, let's call it pooled model. We're using the PLM function. So this is not LM class, no? LM, the one that we used before. PLM, this is for panel data. So this is specifically good for panel data. And then we identify the dependent variable investment associated with value plus capital. Same thing with LM class. And then we identify the data. And then we identify the model class. The model is equal to pooling. Okay, so let's run this class. Let's run this. Okay, so what do we see here, class? Same thing, class, pooling. So this is the formula that we used. Panel linear model, investment associated with value plus capital, data is equal to P data, model is equal to pooling. And you can see here, balanced, N is equal to 10. So R was able to determine if this is a balanced panel data by virtue of the index, class, and the time. So M is a number of units, 10 units. T is a number of periods, so 20 years, and then N is equal to 200. So that's small n times T, that's big N, number of observations, okay? And it's a panel data. Okay, then we have here the residuals, minimum and then maximum, and then this is our model class. Okay. So we can write that our our model is equal to, if we write this class, okay. So we have investment, okay. Notice if you write this class, you write it investment sub IT. When we did our wage data class last time, it's only wage sub I. The I here refers to the individuals or the units. So since the wage data that we used before did not have any time component because it was a cross-sectional data. So the time did not vary. So there was no need to put the T here, class, because for the wage data set that we used before, the time was not, but the time was invariant. It was not changing because it's a cross-sectional data. If you're using a time series data, let's say you have a data, let's say wage data also, and then it varies across time, then you can write T here. Okay, across time, but there's only one individual. So you don't have to write wage IT because the I there is invariant. You're just taking a look at it, let's say, for person number one. Okay, so that can be written as wage sub T. For this one class, there are 10 units and then there are 20 years. So that's why when you write this, your dependent variable investment sub IT, and it will be equal to, so our model is negative 42.7. Let me just drop the decimal places. Plus 0.11, okay, times value I sub IT plus 0.23 capital, I'll just shortcut it, sub IT, okay, and then plus epsilon sub IT. Okay, you now see the distinction, class, no, between how you write your cross-sectional data. For cross-sectional data, it's only wage sub I. For panel data, you have two components. You have I for the unit, because the unit is not constant. You have 10 units. Okay, so if you're taking a look at the forecast for unit number 10 in year 1940, so that should be investment unit 10, comma 1940. Okay, so let me pause for a while and ask you if this distinction between your panel data, your cross-sectional data, and your time series data is clear, class. Is the distinction clear? Okay, good. Waiting for the others. All right, thank you. That's good. Okay, now what happens, class, with the pooled OLS? So recall this is pooled OLS, class. No? We use pooling. Now, pooled OLS, class, is a type of panel data regression where we disregard the individual component and the time series component. So what do I mean by disregard? So if we go to our data, class, let me erase. I hope this is clear, class. I'll erase it. No, here. Let's go back to our data here. P data. Okay. Note, class, that the P data is the same as your data, your Grunfeld data. The only difference is that now take a look at your index, class. For Grunfeld, class, the index is just 1 up to 200, right? Here, 1 up to 200. For panel data, take a look at your index. 1-1935 up to here 1-1954. So the index was changed, no? The index was changed, class. It indicated here the unit dash the time period. Okay, up to the end here, 10-1954. Okay, so I hope, did you get this, class? Kindly check your P data, class, and see if your P data has the same index now. Kindly chat, please. Okay, thank you, Chard. How about the others, please? Is your P data now, does it now have a different index, class? Thank you. Thank you, Chard. The others, please, class. Waiting for your response. Okay, good. Okay. A few more seconds for the others. Okay. So what happens, class, with a pooled OLS? For a pooled OLS, class, this is what happens. It will disregard this one. Okay? It will disregard your firm and your year. So it will treat it like a cross-sectional data. So what does that mean, class? It will treat each observation as separate observations. In other words, class, it will not treat this observation as Unit 1, 1930, 1951, for example. It will ignore that, class. So it will just be like a cross-sectional data. So that's what happens when with a pooled OLS. Pooling, okay? Pooled OLS, it disregards class the time component, the individual component, and just takes a look at it as a cross-sectional data. Okay, so that's what happens class with a pooled OLS. Okay, let's take a look at this again. May question ba dito? Chard, you have a question?
Sir, nilagay ko lang sir yung code so far po.
Okay, okay, sige. Thank you, Chard. Okay, thank you. Okay, for the others who you may copy this who are not able to follow along. Okay, all right. So now we can see class that the total sum of the squares is 935990. Residual sum of the squares 17590. Adjusted R squared is 81%. Okay, and so it means that the model can explain 81% of the variation of the investment, which is the dependent variable. Okay, total sum of the squares is this amount. The one that's not predicted is 1755. Okay, you can get the ratio of that. It will give you around 19, around 18% something. So that's the variation in our dependent variable that can be explained by our model. Okay, so is this good or bad, class? We'll see, class. We'll see, because we'll have to compare it, class, and we will see if the if the assumption that we just disregard the individual and the year is valid, because the assumption there is saying that there are no differences between the units. Okay, so unit one is not different from unit two or unit three or unit four. That's the implicit assumption there, class. We will just disregard one and the year, class. Is that it's because there is no, if you compare the unit one and unit two and unit three and unit four, there's no difference. Okay, so no need to do the categorization as unit one, unit two, etc. Or also the years, class. Over the years, it's not changing. It's the same. 1935 is not no different from 1936, 1937, etc. until 1954. So that's the underlying assumption there for a pooled OLS. Okay, now let's see, class. The next model that we're going to take a look at is the fixed effects. Okay, fixed effects model. Okay, so we'll not discuss now the what does fixed effects mean. Let's just run it first, and then I'll I'll request you to please do some a little research, class, and try to see the difference between these three methods: the pooled OLS, okay, the fixed effects, and the random effects. Okay, so this tells us that this controls for unobserved heterogeneity. Sorry. So heterogeneity, class, means that there's a difference. Okay, there's a difference between the units. Okay, unobserved heterogeneity means differences in the genus and or in the classes in the units. Okay, so the function is, okay, let's create another object. We can name it FE, fixed effect model. And then the difference here is that model is equal to within, class. Model is equal to within. All right, so let's run this, class, and see what does FE model give us, class. Let's run. Okay. And before we look at this, class, let's take a look at our FE model here. Here, class. It's a list, class. No? Unlike the, okay, it's a list of 10 also, just like the pooled model. And if we view this, class, okay, taking some time. Bakit ako nag-error? Why? Bakit error? Wait, is recursive and is primitive. Okay, sige. Let me, yung pulled naman, error din. Nag-error yung ano natin, yung, error ba rin yung pulled yung class? Could you kindly check? Pero may result, no? Okay, I'm wondering why. May result naman siya. Let me check class, no? Tingnan ko lang yung names, pulled, pulled model. Ayan, no? Okay, and siya. Tapos class, tingnan natin na pulled. Let's just check if it's working, no? Dollar coefficients. Let's check the coefficients. Ayan, class. So it's there. Okay, I just don't know why it's not printing here. Okay, anyway, that's but the model is there, class. I just don't know why it doesn't print here. Ayan naman siya, no? Okay. Oops, sorry. All right, summary, let's check, class. Summary, let's see how this looks like. Uh, Notice, class, kay pulled, no? Pulled. It says here it's balanced, no? And these were the results that we generated a while ago. And then let's take a look at how different is the fixed effects, class. Okay. What do you notice now about the difference? So fixed effects, class, notice that the notice, class, that the intercept is not here anymore, no? Walang intercept, class, dito. Okay? We'll explain next time, class, why i-research yung class why there is no intercept here. We'll discuss that next meeting. Kasi dito sa pooled OLS, we have the intercept here, right? Here. Where's our pooled here? Intercept, class. This is our intercept, right? Okay, for the fixed effects, why is the intercept no longer reflected here? And the 0.11, 0.31, are the coefficients the same? 0.11, 0.23. So there's now a difference between the values of the pooled OLS, the estimates, the coefficients for pooled OLS and for fixed effects. They're no longer the same, class. All right, this is for our, wait, this is our pooled OLS, 0.1155, 0.2306, and there's an intercept. For our fixed effects, okay, let me rerun this summary. Okay. The intercept is gone, class. 0.11 and 0.31, and the estimates are different, class. Iba na, no? Iba na yung estimates. And then, the adjusted R squared, 0.75, is less than, class. It's less than dito, class, adjusted R squared is 0.81. Right? 0.81 here, it's 0.75. So the adjusted R squared for the fixed effect model in this case is lower. And take a look, class, no? The degree of freedom change. So this is now 2 degrees of freedom. This is now 197. Okay. So if you recall, class, let me just Let me just make sure that you understand this, class. So, di ba, ito yung F statistics natin, no? F stat. You have degree of freedom 1 is equal to 2. And degree of freedom 2 for the pooled OLS, that's equal to N minus K minus 1. N is number of observations, minus K is number of predictors, and minus 1. Why do we subtract minus 1? Because we're summarizing, we're computing also the intercept. So you lose 1 degree of freedom for the computation of the intercept. That's why you have 197 for your degree of freedom 2. Now, in the case of the fixed effects class, okay, why do you now have 2? Okay, yeah. 2 also class, okay, because you have 2 predictors, right? Price and capital. And then, why is this now 188? What happened, class? Why is this now 188? The other one was 197. This is 188, class. So I'd like you to look at that, class, okay? And then the adjusted R squared is 0.75. It went down. So does that mean, class, that our pooled OLS is better? 0.81. Is pooled OLS now better than your fixed effect by virtue of it having the higher adjusted R squared? Okay, let's postpone that discussion, class. Okay, let's hold that in abeyance. Okay, so let's now go to the third model, which is random effects, class. Okay, so what I want you to do, class, before Thursday is number one, please find out the differences between the pooled random effects and fixed effects. Okay, and how do you know, class? Uh, we'll still have time to see the basis, class, if which is the better model? Is it pooled? Is it fixed effect? Or is it random effects? Okay, so let's first take a look at the random effects model, class. Okay, and the assumption here, I wrote here briefly, class, no? The assumption is that the individual effects are uncorrelated. The individual effects are uncorrelated with the explanatory variables. The explanatory variables are value and capital. So how do we do the regression here? RE model, can name it any way you want. And then the difference is that here model is equal to random. Here model is equal to within. Here model is equal to pooling. Okay, you can see the difference, no? Model is equal to pooling, model is equal to within, and model is equal to random. So let's run this. All right. And you can see here that this is another output class, no? The intercept is here again, class. The estimates, value, and capital are quite different from from your fixed effects, no? So fixed effects walang intercept, di ba? The coefficient, the parameter value, class, has a value of 0.109781. It's also statistically significant. Tapos ito din, class, capital, 0.3081. It's also different from ito, 0.31 to. Slight difference. Okay? And it still tells us here that it's a balanced panel data. Okay? And then iba din yung residuals nila, no? Quite different residuals. The estimates are different. Okay, and here, class, the adjusted R squared is 0.76. So, and notice, class, here, okay, there's something here, class, yung effects and theta that's not present in the other two. Now, this is very important, class, which I want you to research on. What is this idiosyncratic variance? No? And a share of 28.2%. Ano tong individual na to? 2784.46, 7089.8980, and that's 71.8%, ito 28.2%. Now, in order, class, to understand what is random effects, you should be able to understand this, class. Okay? And I want you to do a little research. Madali lang naman yung class. Also understand what is theta. What is this 86.12? What are these metrics in random effects? Okay, this is the method Swami Auroras, no? That is not found in fixed effect model. It's not found in fixed effect. Wala ditong idiosyncratic at saka individual variance, no? Sa pooled, ganun din, wala, no? So it's very important, class, for us to understand what makes the random effect model, class, compared to your fixed effect or your pooled. Okay, so what would be our decision? Will the decision be based on the adjusted R squared? If it's adjusted R squared, class, then pooling will win kasi 81% ang kaya niyang i-explain. Ang last will be si random effects kasi 75% lang, class, yung ano niya, di ba? 75% lang yung 76 pala. 76 for 7.7. Si pooled 75.31 lang. So based on this, class, adjusted R squared, pooled OLS is the hands down choice as compared to random effects and fixed effects. But is that, class, is that the basis for determining, class? The answer is no, class, hindi. No. So let's take a look at this one. Ito muna, no, ito na lang. Control C. I'll share this with you, class, for lack of time. All right, let's use Stargazer, class, and print the saan na si Arco? Okay, here. Let's compare pooled, fixed effect, random effects, text, okay? And then 4 digits lang. Let's see. Let's print this using Stargazer. And you can see here the differences between them. Okay. So here is your pooled, class. Okay, and dito yung intercept niya. Si fixed effects, class, wala, no? Walang intercept. Si random effects meron. But the predictors, value and capital, in all cases, they're significant. Okay. So we can see here 0.81 yung adjusted R squared, 0.75 for fixed effect, 0.77 for random effects. Okay. And also here, by the way, class, I failed to, okay, tingnan nyo dito, class, no? Dito, class, sa random, notice, class, na iisa na lang yung degree of freedom. 2 degree of freedom. Sa fixed effects kasi, di ba, 2 and 188. Sa pooled is 2 and it's almost time, class. Tapusin ko lang to, class. You may go now. Ito lang yung test, no? I just want to make sure na natapos natin yung test here. Okay, let me share this with you for the AIC, class. Control C. Okay, Control V. Let us take a look at the okay. Compare natin dito, class, yung ano, yung Ramsey, no? Although binigay naman to, class, no, yung root mean square error. Okay? Root mean square error is just the difference between the fitted, ito yung actual value, minus the, okay? This is your, ano yung P data natin? Fitted value, not actual value, sorry. This is your predicted value minus your actual value. Okay? And then yung difference nila squared, class, di ba? And then get the average and then the square root. This is what we call your Ramsey. root mean square error. So if we compute for the Ramsey class, okay, so si pooled OLS ang pinakamaliit na root mean square error. So in terms of root mean square error, pinakamaganda si pooled OLS. Kasi siya yung pinakamaliit na ano class, di ba? Yung adjusted R squared niya. Yung residuals, no? Root mean square error ng residuals class, pinakamaliit si pooled OLS. Alright, now, okay, let me share this with you, class. I'll just stop here, class, no? Ito, Control C, para masabi lang natin na na-discussan natin yung ano, yung how to determine which is the better model class. Again, class, if you need to go, no? I'll just nasobrahan. Galing po to. Very quick, class. We'll redo this next meeting, but I just want to discuss this one very quickly. How do you now test whether which is the best model class? Okay, first, tingnan natin class pooled versus fixed. Basahin nyo na lang to, no? So we're going to use we're going to test class whether the fixed effect is better than the pooled. Ano ibig sabihin nito, class? Ang null hypothesis, walang significant na firm effects, no? So ang pooled sinasabi niya, we can dispense with the firm and the year kasi wala namang wala namang differences dun sa kanila eh. So run natin to, class. And you can see here that the p-value is 2.2. Okay? The hypothesis is that there is no significant firm effects. Walang differences sa mga companies. And then, so we reject that class. We reject that null hypothesis. The alternative hypothesis is that there are significant effects. There are differences between the companies, class. So si firm 1, iba kay firm 2, iba kay firm 3, etc. Therefore, class, between the fixed effect model and the pooled model, class, mas maganda si fixed effect model. We cannot just say that walang differences, no? Walang differences yung mga firms. Okay? So pangalawa, class, let's check now pooled versus random effects. Okay, so we use the Bruce-Pagan multiplier. Okay, ganun din to, class, similar to the PF test kanina. Walang significant effects din. The difference is that ilalagay natin dito type is equal to BP. Okay, ito PF test plus ito PLM test, and then type lagay natin Bruce-Pagan, run natin to, class. So we can see here also that the p-value is less than 0.05. Therefore, we reject the null hypothesis that walang significant effects. May difference, class. May difference ay yung mga individual units. Okay? And lastly, so matitira na lang, class. Talo si pooled, no? So sino sa dalawa? Kasi sabi ni fixed effect, may difference yung individual units. Ganun din naman sinabi ni pooled. So here, class, we use the Hausman test. Okay, and the null hypothesis is that si random effects ang preferred na model, class. So let's run this. And then you can see here the result. Okay, the p-value is 0.3119. Okay, so what does that mean, class? We failed to reject the null hypothesis that the random effects model is the better model. Okay, so based on this data, ang answer, class, we use the random effects model, class. Okay, mas maganda si random effects kaysa kay fixed effects at saka kay pooled OLS. Alright, so let me stop there, class. So we were able to determine, at least based on the 3 tests, quick summary, class, PF test to determine sino mas maganda, si fixed effect or si pooled effects. And then Bruce-Pagan test, class, to determine if it's pooled model, if it's pooled or si random, no? Okay, Bruce-Pagan. And then the result is mas maganda si random. Okay, and then lastly, Hausman test, class, to determine if which is better, si fixed or si RE. And it turns out that random effects is better. All right, so let me stop recording now.